Welcome to the March 2025 News Roundup of the Climate Reflections Podcast. Each month we release a roundup of news related to sunlight reflection methods, or SRM, from the month before. I'm your host, Dr. Pete Irvine. Today I'm joined by several leading SRM experts. Would you each mind introducing yourself?
Hey, I'm Alfonso Fernández, full professor at the Universidad de Concepción in Chile.
Hi, I'm Daniele Visioni. I am an assistant professor at Cornell University.
Hello, my name is Sandro Vattioni. I'm a postdoctoral researcher at ETH Zurich.
Hi, everyone. I'm Tyler Felgenhauer. I'm a senior research scientist at Duke University and the Duke Center on Risk.
So, as always, we kick off our conversation with some of the climate and SRM-related headlines from the past month. So let's start with news from the Intergovernmental Panel on Climate Change, or IPCC. The IPCC recently failed to reach agreement on the timing of its 7th assessment report during a contentious meeting at Hangzhou in China. It did, however, agree the outlines of its 3 main sub-reports, setting to address SRM, or sunlight reflection methods, in its physical science report and its impacts report. You'll be able to find links in our transcript online. So Daniele, you're involved in these discussions. Can you just give us a little bit of background?
IPCC is essentially the scientific part, in a way, of the UNFCCC, so the United Nations Framework on Climate Change. And essentially, the UNFCCC tasks the IPCC with writing assessment reports of the state of the science of climate change, as well as often special reports. And fundamentally, every country in the world, except the ones that decide to leave the process, like at this moment, Argentina and the US, countries' representatives decide what the report should be about, whether there should be special reports and so on, to inform climate policy at the state level. So the IPCC is not for scientists, is not for the public either, but they are to inform policymakers and country states.
Great. And so they've just agreed the outlines for the next report.
Yeah, in December, there was a meeting of the scientists together with some country representatives in Kuala Lumpur that I went to, where essentially these scientists came up with the outline for the whole report.
Gotcha. What's your sort of take on the inclusion of SRM in this report?
Well, first of all, this was the first time that there was a specific mention of the fact that SRM would need to be included in some form. Now, how prominently was it going to be featured? That kind of depended on both the Kuala Lumpur and the Hangzhou meeting. The interesting thing I will note is that there were discussions also for Working Group 3, which is sort of on the adaptation and governance side, while actually at the scoping meeting in Kuala Lumpur, there was no discussion during Working Group 2 of including SRM. Then when the countries saw what was there, a few countries demanded that Working Group 2, due to its focus on impacts, especially on food systems and in general human systems, should be involved, and so demanded a bullet point. So bullet points means that there is no way you can not talk about it during the assessment, and that the author teams have to be assembled based on expertise on the topics of the bullet points. So the presence of SRM means that one way or another, when the Bureau, which means the IPCC chairs and co-chairs, evaluate nominations from country state and evaluate the CVs of lead authors, they need to take into account the presence of expertise on those specific topics, because countries are essentially demanding that they're included.
Well, and I think from what you're saying, crucially, SRM experts will be included in writing up those chapters, because I think that's one of my issues, I think, in some of the previous iterations of the IPCC and its coverage of SRM, is that SRM experts were maybe less involved than they could have been.
Well, how to be involved in an IPCC report is complicated and depends on a lot of things, and also the personal interest of the people being that want to be included. I think it's fair to acknowledge the fact that when it comes to this field, there is a perception that if somebody, and I think we see it often, and we saw it at some discussions at the IPCC level, if somebody is a researcher and therefore an expert in SRM because they've published multiple papers on SRM, they're not as much perceived as expert as much as they're perceived as biased towards SRM because they're doing the research, independently of whatever the results of the research say.
Well, scientists affiliated with the US government were notably absent from the meeting in China recently. So, Daniele, what role do scientists from NASA and the other federal agencies typically play in the IPCC assessments, and what impact could their absence have?
Well, so the people that did not go to Hangzhou were the US delegation, which is actually not just scientists, but mostly on the political side, State Department side. Actually, the chief scientist of NASA ends up also being one of the working group 3 main chairs, so she was also not there. And the technical support unit for working group 3, that was also hosted by the US, that's also gone. So I mean, that's pretty bad. On the other hand, scientists can go also as representatives for observer organizations like WCRP, EDF. So there were some US scientists. There can be no official nominations from the US government, but observer organizations, bureau members, other countries can nominate whoever they deem important, and the final decision sits with the IPCC chairs and bureau members. And so the fact that the US doesn't have a focal point, just like Argentina also doesn't have a focal point anymore, and yet Ines Camiloni is one of the co-chairs. So this is going to make it impossible at this moment for government scientists, so NASA and NOAA people, to be involved in the report, but most likely there are going to be still US scientists one way or another.
So yeah, this is just one of the rapid changes that we've seen in the US since Donald Trump was inaugurated. And Shuchi Talati, who we've had as a guest on this show previously, as well as Whitney Peterson, who both work at the Alliance for Just Deliberation on Solar Engineering, wrote an article last week about these big changes in the US. And they worry that the volatility and polarization in the US could quickly undermine the ability to have informed and inclusive discussions about SRM and its governance. Tyler, what did you make of their argument?
Yeah, I enjoyed the piece by Shuchi and Whitney. I think it makes a good contribution to the discussion. I have 4 quick points I wanted to make on it, mostly in agreement, and the fourth more of a nuanced reaction. So in responding to their piece, first, yes, for sure, it's clearly apparent that the Trump administration is engaging in a full-on assault on the ability of the U.S. federal government to conduct any climate research, climate-supported policy, anything related to climate, and really dismantling federal ability to engage on climate in any conceivable way. And this has been well documented following on Daniele's comments, whether it's NASA, NOAA, the U.S. Global Change Research Program, reports being halted, the moves at the EPA to bafflingly attack the social cost of carbon, the NSF, etc. So because of that, the second point, I think most in the geoengineering research community would probably agree that it wouldn't be a great idea at all if they were to engage on geoengineering research, just because of their full-on attacks on climate change policy and their ability to conduct rational policy analysis. To this point, I don't think people in the administration are paying attention to research on geoengineering, which might be a good thing. I see research into solar radiation modification as part of climate change policy research overall. And to the extent that climate change as a policy area, as a research area is being attacked, then the SRM research enterprise is also being attacked. As my colleagues here on the call know, the models that are used to study SRM are the same to study climate change. Many of the people are the same. Many people started in climate change research and started to look at SRM additionally. Many of the agencies are the same. So to the extent that polarization over climate change is an issue is ramped up, then yes, over the long term, this might be a risk to SRM, the SRM research prospects. But finally, I guess I take a more nuanced view to the Shuchi and Whitney's argument that this current environment has suddenly led to a more polarized debate on SRM in particular. So they bring up 2 points. One is this proliferation of state-level bills, really dozens of states that have proposed bans on geoengineering within their state borders. Now, so far, only Tennessee has passed such a bill into law, but there are many bills under consideration. These bills are misguided in my view because many of them are focusing on a chemtrail conspiracy theory where they're assuming that somehow actions are being taken right now by the federal government to inject particles into the sky for various nefarious reasons, which is flatly not true. The other development that they're talking about is the continued operation of private sector companies in the space, such as Make Sunsets and such as Stardust solutions. To conclude on my comment, I don't see this as a sudden polarization of the SRM debate. I see it more as a freezing or a temporary halt in the debate. The people who are talking about SRM are still here. We're still debating the key issues about risk analysis, about the need or not for field experimentation, about the need for governance, about a possible moratorium, about a possible non-use agreement. Those debates remain the same, and I don't see any particular polarization in the SRM debate right now.
So UK's Advanced Research and Invention Agency, or ARIA, was created by an act of Parliament and intends to commit £56.8 million, or about $73 million, to projects that evaluate the feasibility, scalability, and safety of solar geoengineering ideas. They put out a call for proposals some months ago and are set to announce which projects will get funded in May. But just a couple days ago, from when we're recording this, Raymond Pierre-Humbert and Michael Mann, two very prominent climate scientists and critics of SRM, put an opinion piece out arguing that the UK government should pull the plug on this effort. The authors criticized the ARIA program for funding outdoor experiments, arguing that this won't resolve key uncertainties and that this funding could put us on a slippery slope to deployment. Let's start with that technical claim. What contribution could field experiments make to our understanding of SRM, and what would they not be able to resolve? We could get Sandro to jump in.
I think it depends what they mean with key uncertainties. So if they talk about uncertainties or risks of unilateral deployment or termination shock or governance type of things, I think this can definitely, these kind of risks or uncertainties, these can't be resolved with field experiments or field trials, obviously. But nevertheless, I think it's very important, since other key uncertainties like technical feasibility or environmental impacts could be investigated with small-scale field trials. And therefore, I think it's very important to have these small-scale field experiments. We could learn a lot about how the aerosols interact in the stratosphere, or if weather modification or cloud modifications of clouds, if that would work or not. And therefore, I think it's very important to have these field trials.
What's your reaction, maybe Tyler, to the idea that conducting field experiments would put us on a slippery slope to deployment?
I haven't seen any evidence that it does or that it would. In fact, right now I see if field experiments are not conducted, that the slippery slope is some sort of uncertain type of unregulated deployment. The point of the field experiments, as I understand it, is to learn more about both the effectiveness and the real climatological and biophysical risks of these SRM approaches. Maybe it's a naive approach, but I'm confident in the scientific process that if a certain number of field experiments were conducted that shows that these methods are extremely risky, extremely damaging, then the whole enterprise would be shut down. But as of now, the indoor experiments are pointing us towards the need to understand more about its possible benefits.
Yeah, it might be worth noting here that the Arctic Ice Project shut down recently after discovering some of the risks. So in that case, they did field experiments. I'm not sure if the results they discovered were separate from those field experiments, but they discovered concerning results that led them to shutting the project down. The authors also take issue with the fact that ARIA is not just going to be funding research in the UK. They opened it up to international experts to submit proposals. They suggest this would allow unregulated research in places with weaker environmental standards. Is that something we should worry about, or is this a positive development? That they're funding things internationally?
I will be very blunt and honest and say that, as always, Michael Mann and Ray Pierre-Humbert do not read the things that they comment on. And one of the examples is exactly the working paper that ARIA put out on this topic, where they explicitly say that they would not allow for shopping for countries with weaker environmental regulations. They explicitly say the opposite, and that they do have a governance framework in which they evaluate these proposals. So that's a absolutely false concern. And as far as funding research also outside the UK, every time we keep hearing and in a way agreeing of the fact that these kind of research cannot happen only at the local scale, but should be international. But then every time somebody tries to do that, like ARIA, but also like what the National Academy of Science in the US said, then the concern gets shifted to, well, but how about that? And the answer is always, you can only evaluate things, but what they produce. if there's any impression that ARIA is funding outdoor research in places with weaker environmental regulation, then it would be absolutely fair to criticize and attack both ARIA and whatever group is trying to do that, because that's clearly lacks the transparency that would be necessary.
Now to some scientific papers that came out recently. There was a paper published in Nature Communications, Earth and Environment that was on the impacts of using solid aerosol particles of alumina or calcite for stratospheric aerosol injection, or known as SAI. Now this would be instead of what we normally focus on in studies of SAI, which is sulfur dioxide, the same thing that volcanoes emit. We are lucky to be joined by the lead author of this piece, who has also just published a perspective on this topic that'll be on our website. So Sandro, why study these alternative solid particles for SAI instead of sulfur dioxide?
Yeah, as you just said, most research on SAI focuses on the injection of SO2, which is a sulfur-containing gas, which afterwards forms sulfuric acid aerosols in the stratosphere. And this follows the analog of large explosive volcanic eruptions. So that's also where the idea came from and how the whole idea of SAI evolved. And therefore, most research is focused on these species. However, recent studies have shown that solid particles, such as, for example, calcite, alumina, or even diamond particles or so, they would scatter radiation much more efficient. So you would need less material in the stratosphere to create a certain cooling effect. And they would also, that's most importantly, they would also decrease some side effects of SAI, such as, for example, stratospheric warming, which then could have a dynamical response on the global atmospheric circulation, or also the impact on stratospheric ozone could be reduced when using solid particles, or you could decrease, it could decrease the amount of diffuse radiation at the Earth's surface. So there are potentially many advantages of using solid particles over sulfur species.
Well, if I might jump in, so sulfur dioxide has the advantage that volcanoes do this every so often. They emit every so often many megatons into the stratosphere, and it has these various side effects, though those side effects aren't that big, and they're also quite well understood. Is there a trade-off here between quite well understood risks on the one hand and possibly lower risks, but much more uncertainty on the other with these alternative particles?
Yes, you're asking the right question, because that's exactly what we show also with our study. So even though the impacts from sulfuric acid aerosols are larger compared to, or expected to be larger compared to solid particles, the uncertainty is significantly reduced. The uncertainty of the effects is significantly smaller for sulfur. So we know much more about sulfuric acid aerosols in the stratosphere. And solids, they do not occur naturally in the stratosphere, and therefore there is a lot of uncertainty on the physical and chemical properties of these particles and how they would interact with radiation in the stratosphere. Therefore, currently, someone might call sulfur injection safer because there's less uncertainty, even though effects might be worse compared to solids, but for the solids, the underlying uncertainty is much larger.
So is it something we should be shifting our focus on? Is this an emergent area?
Yes, definitely. Yeah. So we should definitely have more research on solid particles, since all the research shows that some adverse effects of sulfuric acid aerosols could be reduced. So we really need to reduce these uncertainties of solid particle SAI, because not doing so could risk a biased assessment of SAI as a whole. So if we only look at sulfur and really assess, perfectly assess SAI via SO2, that might be give a false picture, and solid particles would reduce many of the negative side effects of SO2. So therefore, it's important to do this research now, before we have this final or this assessment on SO2 ready, because we really need it timely. because currently also we don't have the model capacities to model solid particles with many models. There are one or two models which can do that at the moment. And if it really turns out that solids would reduce some of the side effects of SAI, then we should already have the tools to investigate to investigate SAI with solid particles. And but until we are there, we also need a lot of experimental work. So as I said, many of the physical and optical properties of solid particles are not, or there's a lot of uncertainty on that. So we need to do these lab experiments and to investigate this now, because not doing so could risk a biased assessment of SAI.
Well, please do check out Sandro's new perspective at srm360.org in the perspective section. There's another new study in Nature Communications, Earth and Environment by Liyun Zhao and colleagues, which is focused on approaches which might help to keep marine glaciers together. Now, this wasn't focused on solid engineering ideas, but an idea that attacks these glaciers from the other side, rather than from the atmosphere down, from the ocean up. So, Alfonso, can you explain what is a marine glacier and how is it different from the glaciers our audience might be familiar with?
From the glaciological perspective, there's no such a thing as a marine glacier. We have a different definition usually for that. I think they are thinking on a glacier that ends on the ocean, on a fjord. In general, what we call them, because part of the way they discharge ice is through ice detachment on the front, we call them calving glaciers. It's one of the typical glaciers around Antarctic Peninsula, Greenland, and many areas with fjords. They have relatively high sensitivity to oceanic temperatures.
Just to clarify, most glaciers sit up a mountain and they just are affected by the atmosphere around them. But these ones sit close to the water, and so the ice starts on a mountain or on an ice sheet and rolls out onto the water where it can snap off as icebergs. How are these glaciers affected by climate change?
As soon as we have high temperatures, there is mass loss, or there are more precipitation or solar precipitation, there is mass gain. And the glacier is going to fluctuate its volume according to those inputs and outputs and a flow property. But those glaciers they're on the limit, or are actually touching, or on the fjords touching the water. They have an additional dynamics, which is this interaction between the ocean or the waters, because this also happens on lakes. There's calving glaciers that goes to what we call fresh calving, and on the marine area we call marine calving. Those glaciers have this extra dynamics that sometimes make the glaciers as a whole behave differently. So there are many examples, for instance, in Patagonia, that a glacier might have a we call positive mass balance. It should have grown in 20 years, but actually lost mass because the dynamics on the front was different. So there was this more ice discharge. And that dynamics is related to the ocean or the marine temperature. So when there's higher temperatures, we should see higher melting below the bottom of the glacier that is touching the water, and that will make the front weaker, will produce that there is more breaks of the ice blocks, and then more detachment and more ice loss. That will increase the sea level.
Yeah, so to paraphrase, it's not just the fact that there's more melting happening at the ocean front, which is sort of eating away at the ice. It's that once you've eaten away the ice at the front of the glacier, the rest of the glacier can flow in and snap off more quickly. So this research, they were looking at an intervention. It's not solid engineering, but it's kind of a related concept of putting up a barrier underneath or near that fjord to prevent warm water or slow warm water from entering and getting below the glacier. Now they found it didn't really work very well. So what was your reaction to this piece and to that general idea of these glacier bed curtains to hold back the warm water?
The first assumption for them is that the ocean had an important impact on the overall melting of the glacier. But what we know is everything is all related, right? There's many other components to the glacier behavior. But in addition, those things are connected to the flow of the ice itself. And that makes the glacier to respond with a certain delay in time. So what we know from experiments in other parts of the world is there's something we call committed loss or committal volume loss, which means that even though if we stop any global warming right now, glaciers, because their flow properties, will continue shrinking for a few decades. That will mean that their many interventions shouldn't work as expected in a way that will restore the volume that we will see. That probably will slow down a little bit, as we see here in the paper. It's not like it's doing nothing. It's just a weak, very small change in the length of the glacier. So that's probably not going to be, as the experiment shows, a super important impact on the actual response of the glacier to climate change, which suggests in a way that if that experiment will work, we will need, at least for this setup, maybe even higher cooling of the ocean to make any more impact.
And so maybe to take that to the larger scale, if we were to deploy solar geoengineering to hold temperatures at today's levels, sea level rise would keep going for centuries, right?
I don't know for centuries, because it depends how it's implemented, how much cooling we'll be able to do with some sort of actual geoengineering deployment. But all these platforms, ice platforms in Antarctica, and all those glaciers going down the ocean, and even mountain glaciers that contribute to sea level, they're going to continue shrinking for the next few decades. There's nothing we can do to stop it at zero right now.
Let's wrap things up. I want to shift over some questions and comments we've got from our website. So first, we had a question from a listener named Bill. Are there any current test projects, which I'm going to take to mean field experiments, involving SAI? Sandro, do you want to jump in on that?
Yes, I think currently there are no field experiments, or not to my knowledge, which are being performed outside. There are plans, like for example Scopex a few years ago, which couldn't be performed. They didn't get the permission to do that from the local government. But I think something like this would be, as I already mentioned before, it would be highly necessary to reduce uncertainty, how aerosols evolve in the stratosphere. What would be required in terms of injection amounts is less than a commercial aircraft would inject during a transatlantic flight. So it would be very little, which could already help a lot to learn a lot from these, not only for stratospheric aerosol injection research, but also like for other sorts of aerosol plumes, like volcanoes or so. It would not be only beneficial for SAI, but for other fields of research too.
Yeah, so just to add on that, I mean, so ARIA might fund some new SAI experiments. They're going to be funding various field experiments, so we might see more there. There's also Stardust Solutions, this commercial effort, which is planning or is doing things perhaps in the next couple of years. And then there's Make Sunsets, which is not doing experiments. They're actually doing very small scale releases to have a cooling effect on the climate.
That's probably not significant to create a global effect. And it's also not scientific what they're doing.
All right, and we've got one last question from the Carbonaut, which I'm paraphrasing a little here. How will SRM interact with carbon dioxide removal, and how is this accounted for in climate simulations?
I think it's a very interesting question, because I think for the impact of solar radiation modification would probably, for most carbon removal techniques, it would not have a big effect, like for example direct air capture, enhanced rock weathering or so. But one technique which has quite a big potential to take up CO2 or remove CO2 from the atmosphere is increased ocean alkalinification. And in this respect, I think SRM could have a big effect, since if we would cool surface temperatures, this would also cool the ocean. And when the ocean is colder, it can take up more CO2. So SRM could, in a way, help reducing the CO2 concentration in the atmosphere. To how this is represented in climate models, I think just the climate models I'm working with, they often, or they always prescribe the CO2 concentration with a scenario of like socioeconomic pathways. So there is no interaction between the CO2 concentration and SRM, but obviously there is. These are coupled, and this is also a thing which could be more researched in the future, I think.
Yeah, I just add, I think in the same ways that, or in similar ways to the way climate change could affect these various things. So if you're growing bioenergy crops to try and capture CO2 that way, and that's impacted by climate change, it'll also be affected by SRM. And yeah, I think Sandro's right that there's often a sort of we've got a patchwork of different models addressing different parts of the problem. And so the parts which look at CDR and how it works are often a different part of the ecosystem from the ones that look at the consequences of SRM. So there are these interactions, but they're often not captured because people are looking at different parts of the problem. Great. Well, thanks everyone for joining. That's the end of our monthly news roundup. Thanks a lot for joining.
Thank you.
Thank you. Thanks.
Thank you. Thank you very much.
Thanks for joining us for our monthly news roundup. Tune in for more episodes of Climate Reflections. And if you like this episode, please rate and review us wherever you got this podcast. The Climate Reflections podcast is a production of SRM-360, a non-profit knowledge broker supporting an informed, evidence-based discussion of sunlight reflection methods. To learn more about SRM or to ask a question, visit srm360.org, where you can also find a transcript of this episode with links to the articles we discussed.